Welcome to our second day of looking at chemical reactions in the kitchen. Um, on the other day, we looked at a really simple chemical reaction that's happening in your kitchen, and that's your propane burner. If you have a gas stove, whether it's natural gas or propane, whenever that uh, flame is happening right there on your stove, there's a chemical reaction right in front of you. And what's happening is you have some reactants, different substances that are reacting together, and then they get changed into some new substances. Two new products and some energy is released in the form of heat and light. So in this case, you have propane, which is made of 3 carbon atoms and 8 hydrogen, and that combines with 5 oxygen molecules. One oxygen molecule has 2 oxygen atoms in it. You just need a spark, and then it combusts, and those atoms, they don't disappear. The bonds holding them together, they're stuck together, they separate, releasing energy in the form of heat and light, but then they stick back together in a new configuration. So the carbon that were now in propane end up becoming a gas, and they bond with some of the oxygen atoms from the oxygen molecules, and they make 3 CO2 molecules. And then the hydrogen that was in the propane bond with some of the other oxygen atoms, and they make 4 water molecules. And that's what a chemical reaction is. It's when you have some reactants, the atoms, the bonds holding them together are broken, they recombine and form new substances or products. So a simple version of what's going on here has to do with individual atoms. And here we're looking at a couple different models of atoms, going way back to 1803 and John Dalton's model. Most students are probably familiar with this model, the Rutherford model or the Bohr model, where you can see these electrons, subatomic particles, surrounding a nucleus. And the nucleus has 2 kinds of particles in it, neutrons and protons. The protons have a positive charge, and then the little electrons out here have a negative charge. But since these are on the outside, those are what the electrons on one atom are what cause them to either stick or not stick to another atom. And that's where chemical bonding comes in. Now, one chemical reaction you've probably seen in your kitchen before is, or in class, and you've probably seen it in the kitchen, you just didn't realize it, is baking soda and vinegar. And if you mix baking soda and vinegar, most people know it fizzes, and you get this foam. But more importantly, those bubbles are evidence of a chemical reaction because inside the bubble is a gas. It's colorless and odorless. You can't see it. But one way you can prove it's there is by pouring it onto a flame. The gas happens to be carbon dioxide, and you'll notice that, and carbon dioxide we know does not support a flame or combustion. So when I added that flame, it went out. And now I can take the carbon dioxide that was produced from the chemical reaction of vinegar and baking soda, and I can pour that carbon dioxide into another beaker, and it'll put the flame out. And then if I try and relight it with the same lighter, it won't work because there's carbon dioxide in that beaker now. Now, if I pour that carbon dioxide out and it refills with just the surrounding air, all of a sudden I'll be able to relight it. There you go. So what happened there is you had acetic acid or white vinegar reacting with sodium bicarbonate or baking soda, and it ends up producing sodium acetate, water, and carbon dioxide. And carbon dioxide is the gas you see in those bubbles, and those bubbles are evidence that a chemical reaction happened. The other chemical reaction you might be familiar with is seeing sugar burn. And it doesn't take a lot of heat to burn sugar. Here what I'm doing is I'm putting salt and sugar onto a piece of aluminum foil, and I'm going to burn both of them, or I'm going to try to burn both of them. So there's some salt, here's some sugar. And one place you've probably seen this is if you've ever toasted a marshmallow. There's a fine line between getting the marshmallow just a nice caramel brown color, or between it being, a flaming torch. And then it's your choice to eat it. It's going to taste very different depending on how much you cook it, but it doesn't take a lot of heat to get that caramelization process working. And you can see right here that we're seeing a color change. Not only is it on fire, but it's bubbling. The solid is turning into a liquid. It's melting, which isn't necessarily in itself evidence of a chemical change, because that's just a physical change if a solid turns into a liquid from heat. But we are seeing a color change, and a color change generally means that a new substance was made. And this here, you're seeing caramelization happen, or the Maillard reaction. So you get a whole bunch of different flavors, and it started off where I was making some caramel, but now I'm pretty much I burnt the sugar. Uh, the other thing to take note of, though, is when you look at this closely, you can still see there's a little bit of salt. So if I move this around, we'll be able to see whether or not the salt burnt, if that was enough energy to cause a chemical reaction in the salt. And it was not. So more on salt later. Today, what we're going to do is make pancakes. So we're going to tie some of these ideas together and make pancakes. And we're going to cook using a ratio. We're going to use the 2-to-1, 1/2 ratio. There's several ratios you can use for pancakes, but this one works pretty well. And what this means is there's 2 parts liquid, usually milk, 2 parts flour, 1 part egg, and a 1/2 part fat. And that fat could be oil or melted butter in your pancakes. There's a few other ingredients. So if you're sitting at home saying, wait a minute, what about this? What about this? Don't worry, we're going to get to that. But if you bake with ratios like this, you can adjust your recipe based on how much ingredients you have. So if you remember the 2-to-1, 1/2 ratio and which parts go in there. So the first thing we're going to do, we're going to get our basic ingredients. I've got some flour, milk. I'm using canola oil. You could use any kind of oil or melted butter for your fat. I've got some baking powder, some baking soda, some salt, and I have some sugar just off camera here. And I'm using 2 bowls, one for the dry ingredients, one for the wet. And then here's my measuring cup that will be my part. So when I say 2 parts this, I'm going to use that cup to determine those. The first thing is I'm going to put in 2 parts flour. And for me, I used a 1/2 cup as my part. I didn't want to make a ton, so I just used a 1/2 cup. So I filled it twice, 2 parts, and I put the 2 parts into the bowl for the dry ingredients. Added a few other dry ingredients. You could put 1 to 2 tablespoons sugar in there. Remember, sugar burns with heat, so the more sugar you put in, the higher chance you could burn your pancakes, but the sugar helps them get a nice brown color. You put in a pinch to like a 1/2 teaspoon salt, depending on how much you want. And then to have a chemical reaction, we're going to put in baking soda and baking powder. I usually put in about 1 to 2 teaspoons of baking powder and a 1/2 to 1 teaspoon of baking soda. Now, some people are like, well, what the heck's the difference? Well, baking soda, sodium bicarbonate, you know that this will react when there's an acid, and it will make CO2. Baking powder has baking soda in it, but it has a couple other things, and it depends on which type. And when it says double acting, that means 2 things. Number one, that it will start to produce some CO2 in the presence of an acid, but it will also produce CO2 once it's mixed with water and it's heated. So you have a time limit on this, but once you mix those ingredients and you add the liquid ingredients, you have a certain amount of time before you need to get that pancake batter into the pan, and that heat will cause the chemical reaction, and it will produce CO2. So take a whisk or a fork or a spoon and mix those dry ingredients so they're all in one bowl. And then we're going to mix the wet ingredients. So remember, we had 2 parts flour, 2 parts liquid. So I'm going to use a 1/2 cup, and this time I used a liquid measuring cup. So a whole cup, or 2 times 1/2 cups, 2 parts in the bowl. 1 egg, and 1 egg ends up being about a 1/4 cup if you filled it into, I poured it in my little 1/2 cup and it filled it up about halfway. So a 1/2 part egg. You're not using a 1/2 egg, you're just using 1/2 a part. And our part, once again, is a 1/2 cup. So you have to use 1/2 of that for your egg. And then a 1/2 part fat. So I took our measuring cup once again, and I filled it halfway with oil, and I put that in. You could also use melted butter. Just make sure it cools so it doesn't cook the egg. And then once that's done, use your whisk and whisk that all together. Break the egg yolk. Make sure you mix the oil and the egg and the milk. And then you're going to add your wet ingredients to your dry ingredients and stir that around with a whisk or a fork. You want to do this as little as possible. I'm not going to go into detail about why. I'll give you a little bit. If you add water to flour, you produce the protein gluten. And the more you stir it, the more gluten. And if you want your pancakes to have a nice fluffy cake-like texture, you don't want a lot of gluten. If you add a lot of gluten, they'll be kind of stretchy and tough, more like a tortilla or bread. So it depends on texture, but the less you stir it, the better for a pancake. In other recipes, you want to stir it or knead it more. With this, stir it very little. So it'll look like that, it'll look like that. At the end, you'll still have some lumps, and that's good. Stop there. Just try to get the wet and the dry ingredients combined. Stop stirring. And then at this point, if you want to fold in a few extra things, you could. Maybe like some frozen blueberries, some chocolate chips, sliced bananas. If you want to put some spices in, maybe you could do that. It's up to you. I chose to put some chocolate chips and some pecans in this one, and I just folded them in with a spatula. Once again, try not to stir too much. And then use your cup or whatever measuring tool you had. I filled it about halfway, and I put 3 pancakes into a pan, medium heat, and then look for bubbles. You'll know the chemical reaction is happening because you'll see bubbles right here, right here, right there, right there. What that means is that the baking powder and the baking soda are working, and they're making carbon dioxide. That is the product of this chemical reaction. Just like when you mixed it with vinegar, it made bubbles of carbon dioxide. Well, now it's making carbon dioxide. And that causes the pancake to rise, and it makes it light and fluffy. Make sure you flip it before they burn. If you have a small spatula, you can scrape it under there and look and check what color it is. And if you have it like right at the amount of browning you want, flip it over. Once you flip it over, there's your pancake. Enjoy it. Maple syrup, pancake syrup, jam, jelly, maybe powdered sugar, or just plain. They're good. So enjoy your pancakes. Good luck making them, and be safe in the kitchen.